Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic name is traveling salesman problem using dynamic programming. This topic you will find in third unit as the last topic of third unit. So as far as the video is concerned, we will be going to talk about three different things. The one is what is traveling salesman problem now and how to apply dynamic programming on it. The third is we'll take some example problem and we'll solve using dynamic programming method. Now let's move. So what is traveling salesman problem? We have seen how to apply dynamic programming to a subset selection problem, that is 0 by 1 knapsack problem. Now we turn our attention to a permutation problem. Note that permutation problems usually are much harder to solve than set problems, as there are n factorial different permutations of n objects, whereas there are 2 power n different subsets for n objects. Obviously n factorial is greater than from 2 power n. So that's what these are little bit hard problems. Now so let G is equal to V comma E and it is a directed graph with edge cost Cij is defined such that Cij is greater than 0 for all I and j. Cij is infinite if that ij is not belongs to edge. Now understand this traveling salesman problem with the example. Let us assume that a salesman A wanted to sell the products what he has in a tour or by visiting the other places. Now he wanted to visit S1, S2, S3, S4. These are the cities what he wanted to visit. Now he is planning a tour among these cities. Let us assume this is his home city. So that this is what is the starting vertex or the home city. So naturally from the home city he can go to S2 or else he can go to S3 or else he can go to S4. So in stage wise he can take a decision depending upon the minimum cost of the tour. That means a tour of a G is directed simple cycle. Simple cycle in the sense if a salesman has started his tour from S1 city and he has visited all the cities, he should go back to S1 because it is a cycle. If he is living in S1, he has to come back to S1, right? Now, so that is what directed simple cycle. That includes every vertex in V. He has to visit all the cities what are available in the graph. The cost of a tour is the sum of the cost of the edges on tour. The traveling salesperson problem is to find the tour of minimum cost. Now when he starts from S1, he can go to S2, S3, S4. How can he choose which path he has to travel based upon the minimum? So it is a minimization problem. When it is a minimization problem, you can apply dynamic programming. So dynamic programming works based upon optimality principle. What is optimality principle? Problem can get solved using dynamic programming by taking sequence of decisions. We'll take the sequence of decisions in each stage. That we'll see with the example. Now he wanted to start with this city is 1. So when he started his visiting from city 1, he will go to city 2 or else he can go to city 4 or else he can go to the other cities, right? Via the intermediary cities he can go. 1 to 2 he can go and 1 to 4 he can go. So likewise he can visit any of the city. Now keep this in the mind that the way how I have taken this direction is doesn't mean that it will give the same cost. That's what I have given cost adjacency metric. 1 to 2 distance is not same as 2 to 1, right? So it is a directed graph. Now go ahead. This is what the formula to calculate the cost. Now what is G I comma S? That is I is the starting vertex from where we are starting. S is set of vertices what are left. So 2, 3, 4 is equal to, you have to find minimum cost, right? Minimum among all other remaining vertices. So K belongs to S. S is what? 2, 3, 4. The set is 2, 3, 4. Now C, I, K. I is what? 1. That is C1K. So if you are taking K as second vertex, your K value will be 2. If you take K as 3, your K value will be 3. So if it is 1, 2, for which 1, 2 we are asking? The cost from this graph. The cost from this adjacency matrix. If it is C12, you can take C12 value as 10. Now G of K comma S means 2, 3, 4 minus K. So this is what the formula to calculate cost of the tour, cost of in each stage. Now if you observe this, it is a recursive formula. Let us generate a recursive tree to understand this cost. Now how it will be looks like, he is at one city, he can move to 2, he can move to 3, or he can move to 4. So depending upon what he will decide whether he go to 2 or 3 or 4, depending upon the minimum cost. So as far as minimum cost formula is considered, it is a recursive call, right? So that means here the formula is what? 1 to C12 plus G of 2 comma leftover vertex 3 comma 4. So C12 you know from this graph. What is C12? 10. So 10 you will be knowing from the graph. So this value you have to calculate. For again to get this value, you have to draw recursive tree from 2 to visit 3 and 4. So that's what 3 will come here and 4 will come here. So we'll take one more slide. Now let's see here. This is what the possible permutations for this graph. That is, he can go to 1 to 2 or 1 to 3 or 1 to 4. Depending upon the minimum cost, he'll choose to travel. So now, so here at 2, what is the cost here at 2? The formula is what? CIK. I is 1. Started vertex is 1. 2 is what? K value. So from the set, I took 2 as my K value. So now plus G of K comma. K is what? 2 comma. Leftover vertex are 3 comma 4. So this is what I have to write here. Now what is the formula over here? The same. C13 plus G comma G of 3 comma 2 comma 4. The same here. C14 plus G of 4 comma 2 comma 3. Right. Now what is the value of C12 from the graph? So we'll take that graph here. The graph is what? 0, 10, 15, 20. So this graph I have taken from textbook itself, the prescribed textbook. So you can take many exercises from the same textbook. There are many exercises. As far as traveling salesman problem is considered, you have lab experiment to complete. So if you can focus what I am teaching here, I am sure that you can run the program using Java. Right. Now, so what is C12 value? C12 value 1, 2, 3, 4, 1, 2, 3, 4. C12 1, 2. It is 10. But we don't know this value. You have to get it done. So how I can get it done? I am at second vertex. Now the formula is what? C23 plus G of unvisited vertex 3 comma 4. Correct? Now at fourth vertex. Now it is what? C24 plus G of which vertex he did not visited? 4 comma 3 he did not visited at 3. Now the same here also you will get 2. Here also you will get 1. Here 1. And here which vertex? 2. And here which vertex? 1, 3, 2. Here it is 4. And here it is 4. 1, 2, 3, 4. And here it is 1, 2, 4, which is not covered, 3 is not covered. And the next is what? 1, 3, 2, 4, 1, 3, 4 2 and 1 4 3 2 1 4 3 2 1 4 2 3. This is recursive tree. Now write down the formulas. So at 4 the formula is this. Now you can write the formula at 2. At 2 the formula is what? It is the cost of 3 2 vertex. Now write down C32 plus G of 2 comma 4. At 4 C34 plus G of 4 comma 2 3. Now if you see this also, it is not solved. You don't know this value. You know this value. See 2 3 value is what? 2 3 9. You know this 9, but you don't know what is this value. To get this value you have to come down. What it is in the down? That here you should take C34 value plus G 4 comma pi value. There is no other vertex, but he is not visited. He completed all the things. So it is empty. Empty in the sense you can make understand this, that he is visiting the home city back. That means 4 comma 1. You know what is the cost of 4 comma 1, right? 4 comma 1 cost is what? 8. So 3 4 cost is what? 3 4 cost is 12. 12 plus 4 comma 1 cost is 8. 12 plus 8 is what? 20. Now 20. Send 20 up. So this 9 plus 20 is 29. And you should know this cost also. Let's try. So now 3. Here the vertex C43 plus G comma G3 of pi. Now G3 comma 1. 3 comma 1 is 6. And C4 comma 3. 4 comma 3 is 9. 9 plus 6 is what? 15. So we'll send 15 here. Now C24 value is what? 2 4 2 4 10. 10 plus 15. Okay. Now again come here. So here also you will get C24 plus G4 comma 1 value. C24 is 10 plus G4 comma 1 value is 8. So you will send here 18. So you know already C32 value. 32 value is what? 13. And again come here. So here this value is what? C42 plus G2 comma pi. Now this value is what? 8 plus 5. And this value is what? 9 plus 6. And this value is 13 plus 5. So we'll send up. The cost of this vertex, cost of 4 3 vertex also there, no? Cost of 4 3 vertex and cost of 4 2 vertex. And this is what? 18. And this is what? 15. Now again send it back. So here 10 plus which is minimum? 9 plus 20 is 29. 10 plus 15 is 25. Which is minimum? That cost will take here. 25 is minimum. The same. Again from this 2 vertex, whichever is minimum, that will be comes back. Whichever is minimum, that comes back. Among these three, whichever is minimum, that it will come back. So 10 plus 25, 15 plus 25, 20 plus 23. Which is shorter distance or minimum cost? 35 is the minimum cost. So which path he has taken? He has taken this path to travel. So this is the minimum cost what he has got from the cost matrix and cost matrix formula. So that's it. It is about traveling salesman problem. So you have even the implementation part for the same. You can implement using Java programming. Okay. So here you cannot write the solution what I have drawn in the tree. You should little bit move like this. Your answer paper, OU end semester examination answer paper, you should write this way. What it this way? G2 comma pi value is what? 2 comma 1 value. Look at in the graph. 2 comma 1 value. 2 comma 1 5. These values have to be reflected in your paper along with the recursive tree. And 3 comma pi value is what? 3 comma pi, 3 comma 1, it is 6. And 4 comma pi value is what? 8. After that, g2 comma 3 value also you have to write. What is g2 comma 3 value? g2 comma 3 value in the sense that the value is 15. From the last diagram you can write all this. 2 comma 4 value is 18. So how I got this 2 comma 4, 2 comma 3 value? That you can write complete the formula. Then you will be, then you can copy over here. 3 comma 4 value is 20, 4 comma 2 is 15. So from the recursive tree I am writing all this. I am not writing blindly. From the recursive tree I am writing all these values. 25, this is 25 and this is 23. So finally G 1 comma 2 3 4 is, finally G cost of 1 comma 2 3 4 is what? 35, minimum cost. So this is what traveling salesperson problem solution. Thank you all.